Hello there, math fans. Dr. Andy Loves here. We're going to talk about conjugates. It's something that comes up in calculus quite a bit as a little algebra sort of trick manipulation. And it's coming up in my pre-calculus class. My students are asking me about a question that has to do with this. And so I'm just going to give a little more background on what a conjugate is. It's a fairly quick discussion. It ultimately is an example of expanding. So we've talked in class about how if somebody gives me something like this, with a plus and with a minus, it expands nicely. So when we monkey face it out, which this looks like a monkey face, eyebrows, nose, mouth, that looks a weird one. You get something interesting. You get the first term, you get a negative 4 at the end, but the middle terms cancel because you get a negative 2x and a positive 2x. So you get a negative 2x and a positive 2x, and they cancel. So that's that difference of squares maneuver. Now, a common theme when we're solving or working with equations is sometimes radicals are kind of messy to work with, or sometimes we want to move them from the numerator to the denominator. This gives us a way forward. Meaning if I don't want to have radicals on the numerator of this expression, I could multiply top and bottom by square root of 2 plus the square root of 7. That's a really weird thing to do when you first see it. But it's just something about getting rid of the radicals. So now we're going to talk about why does that get rid of the radicals in the numerator. It feels like that's just making things worse. So the denominator gets worse. That's absolutely true. But what can you say about the numerator? Go ahead and expand it. It's a difference of squares. This times this is going to be a square root of 2 times the square root of 2, so it's just going to be 2. We got rid of the radical. Similarly, this times this is going to be 7. But then you say, well, what about the middle terms? That's not going to be nice. They're going to cancel. And so you're just going to be left with 5 times the square root of 2 plus the square root of 7. And so you're going to be left with a negative 5 on top. It's negative 5 over 5, so negative 1. Now, in this case, that doesn't really make a lot of sense because, in my opinion, that's not better or worse. I think there's a time when, before calculators, where people tried to avoid having radicals in the denominator. So they might have done this so that they could then estimate the square root of 2, estimate the square root of 7, and then divide by 5 at the end. So there were numerical reasons that this started happening. So this has been around. I tried to look up the history, but it's as far back as radicals have been around as a manipulation idea. Okay, so how does that apply to us? Well, I grabbed these 3 problems directly from my Calculus 2 lectures. These are examples. They're actually like limit problems. But like in this problem, we were trying to plug in 9 for x, but we can't right now. We can't really at all, but there's a way to manipulate it. We're trying to plug in 2 here. This thing we're trying to analyze, but there's no good way to put the things together. So in all 3 of these situations in calculus, you're going to use the conjugate idea to get rid of a radical. So you're going to do this over this. You're going to do this over this. And the whole idea is just to move the radical. It doesn't feel, when you first see these, like that's going to take you anywhere, but it does. It gives you a way to rewrite the radical in a different place, which sometimes that's all we need to do some of these problems. So it is a special technique, but it's common enough, I thought it worth to make a short little video on this. So in those 3 cases, and then we'll finish with the problem students are asking about, you can see that you're going to get this times this is x, and you're going to get 3 times negative 3, which is negative 9. The middle terms cancel. Again, that all comes back to the whole idea of the plus minus. That's where this is coming from. The denominator is not nice, and typically we don't expand that. But what happens in this problem, and these do come up. This isn't just totally a made-up example, but the x minus 9 cancels. The truth is, I guess they're not equal. This one you can't plug in 9, this one you can, but everywhere except 9 they're equal. Same thing would happen here. You get an x minus 9, So you will see this, it'll pop up. It's one of the techniques like in the second or third lecture of Math 124. And you get this, and it comes up here too. So, and again, there are many situations where you wouldn't do this, but there are reasons sometimes you'd like to rewrite it. So this is going to become 3 plus 2x plus x squared, that's that times that, minus x squared. That's this times this. And again, the middle term cancels and all over this. And it turns out that's a lot easier to analyze as x goes to infinity. So there's a reason we do things like this. Okay, so back to the problem. This is a foundational calculus idea. If you're trying to figure out the rules for the derivative of this, your first step will be this. You'll write the square root. You'll write x plus h minus 5. I don't know why I made my square root so long. Let's shorten it up. Minus the square root of x minus 5 over h. So if somebody says they want you to simplify that until you can cancel the h on the bottom, there's really not a way to combine those radicals, but there is a way to move them around, and that turns out to be enough to do the problem. So we're going to do x plus h minus 5 plus the square root of x minus 5, and then we're going to multiply that. So the reason we're multiplying the top and the bottom, so we're not actually changing the value, we're just changing the look of it. And the point is that this times this and that times that gets rid of those radicals, and there's no middle term. So this is going to become x plus h minus 5. That's this times this, minus that one times that one, x minus 5, and that's all that's going to be left on top. On the bottom, you're going to have h times this thing. So typically, a bit of advice I always have for students is don't expand out the other part. First, expand out the reason you did it, and only expand the other piece if you're sort of forced to. This simplifies a whole bunch. The 5 cancels with the 5. The negative x cancels with this, and so you end up with h over h, and then you get this thing, square root of x plus h minus 5 plus the square root of x minus 5. And then lastly, you can cancel. So that's the idea in those problems. So your final answer will be all of that together. 1 over the square root of x plus h minus 5 plus the square root of x minus 5. So there's a bunch of conjugates. Let me know if that helped anybody.